Hello all. Good evening everyone and welcome to this exciting webinar. I am Suruta Kulkarni, co-founder of GoCrackit, a career advisory platform. We have mentored 10,000 plus students across MBA and other programs. We have worked with students of different programs across IIMs, ISB, XLRI, NDI, amongst a lot of other institutes. We also have a suite of products for emerging and new age careers, including analytics, data science, AI, machine learning. So do stay tuned to our social media pages for more updates on our products and our exciting range of webinars. Let me start with today's speaker. It gives me a great pleasure to introduce Sujoy Roy Chaudhary. Sujoy has an illustrious career across analytics, data science, machine learning, and artificial intelligence across industries. He was in TCS when he started his career as a consultant for major European telecom companies for around 8 years before he joined IIM Bangalore to do his MBA. Post his MBA, he joined Ericsson, where he established the advanced analytics practice along with delivering large scale projects across IoT, network, and service analytics. Sujoy is currently with IBM as amongst others. He leads projects across India, South Korea, and US. He has also won several awards, including the World Retail Award. Sujoy not only has a great industry experience, but he is also a passionate teacher and a mentor. He is a visiting faculty across IIMs and also has significant research papers published at Harvard and other institutes. I can go on and on, but we'll stop here and hand it over to Sujoy. Just one small announcement. For all those who have questions to Sujoy on whatever aspects with regards to today's topic, feel free to put it on the chat. We will take the questions once Sujoy is done with his session. So over to you, Sujoy, and thank you so much for being with us today for this webinar. Over to you, Sujoy.
Thank you, Surata. You were too kind, and I'll just make one correction. The World Retail Award, I did not win it. Uh, I worked for a client in the fashion domain, and and the client won the World Retail Award. It's considered to be the Oscar in retail. So yeah, maybe I should be more proud of that. Anyway, um, let me know if you can see my screen.
Yeah, it's visible.
Okay. So what what I would take talk today is about a set of problems I and others, my colleagues in IBM, have worked on in the last 4 or 5 years. But not just in IBM. This is a problem which has a lot of focus today in artificial intelligence, and that is applying AI in fashion. Now, why is this? So before I do this, I want to bring in a statement. I'll combine two things. One is what you see on the left is an advertisement of electricity in 1910 in New York. And electricity at that point of time was still a luxury, and people were uh, and there were fears about using electricity also. By 2 decades of this, by early 1930s, electricity had become prevalent all over and had changed all industries. Similarly, Andrew Ng, professor at Stanford, and one of the most famous educators in the field of AI, has used the statement AI is the new electricity. Just like electricity changed the world 100 years back, and we cannot think of any device, of any industry which does not use electricity. This is the potential of artificial intelligence. And depending on what you look at, 2 or 3 industrial revolutions But if I look at the steam industrial revolution in the 1760s and the industrial revolution by electricity in the 1890s, by 30 years from that, all industries had changed. These replaced human physical labor. And the artificial intelligence is what is going to change it in all industries over the next 2 to 3 decades. And this will change or replace or augment human mental labor. Now, like all other industries, fashion itself is one of the industries, but it has certain nuances. When we talk of retail and we talk of AI, we may think of problems like pricing. We may think of problems like market basket analysis, whether people buy bread or butter, and then there is this famous story about beer and diapers, and all sorts of retail problems are there. Supply chain problems are there. Demand forecasting problems are there. And these are all interesting challenges. And whilst all these problems are need a lot of techniques and a lot of formal statistical modeling, fashion as an industry is unique because beyond numbers, beyond product metadata, there is something which is inherent, is an aesthetic sense. I cannot just tell you one shirt and one jeans, right? Which shirt will go with jeans is an aesthetic problem. Now, there are two things. The moment because it is an aesthetic problem, there is no one right solution for everybody, right? I may prefer a white shirt, which I'm wearing now. Someone may prefer a blue shirt. Someone may prefer a pink shirt, right? Someone may prefer some sort of combination. So there is inherently a level of personalization. There is inherently a visual element that then still less incorporated into the AI. As of date, is also the element of touch but fitting is important. So fundamentally, fashion is a complex problem. The other thing that I would like to highlight about fashion is that when we look at the adoption of AI, when we look at the problems that AI is used in, the fashion is one place where some of the more fancier techniques have been used. Now, why is this so? One thing is, unlike medical science, unlike uh, areas like banking and finance, the costs of mistakes are less, right? If you get a bad recommendation for a t-shirt, you may be irritated, but it won't really risk your life. It won't really risk your money or savings. So therefore, it's been an area where, as data scientists, we have been able to experiment more and sort of bring in some of the latest and greatest techniques. Now, in this talk, I will go through not through the details of the models, etc., which is very interesting, and I find it very interesting. But I would rather sort of show that why is AI inherent in many of the fashion problems, and underneath it, you have all the latest of greatest AI techniques. You name it and you'll find it: deep learning, multimodal recommendation engines, single shot learning, triplet loss, and self-supervised learning. All of those, the fanciest terms that AI practitioners use, uh, uh, language models, LSTM models, all of those fancy terms, all of the fancy models are underneath the hood. But we will not go into what's underneath it. That's a different audience, and we have to take a different approach to it. But we will sort of the sort of problems that can be handled and have been handled. Most of these use cases are problems that uh, I and my team or my colleagues have directly worked on. I will show some screenshots, etc., of what is publicly available. There is some stuff which I cannot bring because they are still in a much more experimental and internal state. Uh, Fundamentally, if I look at the fashion use cases, there are two sets of problems. One is the experience problem, where someone tries to experience the products, and then there has been, to be honest, lesser amount of work, but there are a couple of interesting use cases around creative AI, right? And so we will bring together this, and again, this is not something that's happening only in for IBM and IBM's clients. This is something which is very common, but I will try to take use cases which I know are real. So these are not wish lists. These are not dreams. These things actually exist. Now let's start with a fundamental problem. Can we replicate the offline experience in an online world? What happens? Just think of what happens when you walk into. I know due to the pandemic, we've not gone into a store for a long time, maybe. But if you walk into a fashion store, or say a Shopper Stop, or Fab India's showroom, what are the things that happens? Uh, your customer walks in and asks for a product, and then there is a discussion. The salesperson would ask, sir or madam, what do you want? What sort of price range are you looking at? Are you looking at a specific brand? Are you looking at a specific color? This is a discussion which is happening, and after a few questions, they would show you some recommendations. So this, the first part, is the chatbot, where we can replace this discussion on the online world with a conversational thing, and this will be powered by a recommendation engine. Now remember, it's not enough to have the discussion, and it's not enough to have the recommendation engine. If I am now looking for jeans, if I am shown shorts, I will not be interested. On the other hand, I need to give recommendations which are relevant for the user, for their behavior, for their demographics. And it is here that the online system perhaps does better, because you know the user's history, you know the user's preferences, etc. So you can build recommendation engines, and we'll look a bit more in detail about what a recommendation engine looks like. And then, as the person would be looking, and you may be looking at one, say, blue shirt or a green dress, the salesperson would suggest, madam, why don't you look at this dress also, right? It could be a similar brand, it could be a different print on the same brand, etc. So there would be, most characteristics would be similar, but one or two characteristics would be different, and these are similar products. And then we will look at some approaches that we've taken to solve the problem of similar products. And then you would also want to recommend some top selling products, where these are what's in the trend today. If distressed jeans is in trend today, then suggest to the customer distressed jeans. And then perhaps the most critical piece is the upselling, where if a person is buying a dress, then can we recommend some accessories with it? If a person is buying a T-shirt, can we recommend jeans with that? So that is where we would say complete the look. And finally, there's the traditional billing, etc. What I would like to point out is that all of these require a deep understanding of two things. One is a deep understanding of the product, not only from the attribute perspective. It's not enough to say this is a Levi's jeans. It also needs to understand what does the real color of the jeans look like, what's the what's the print, if it has a print of a t-shirt, that's maybe more relevant. uh, so it needs a deep understanding of the product from multiple dimensions, and we call them multiple modes of data. And I'll just talk briefly about what we've done on multimodal work. And also, it is a AI field where it's important to understand these how these aspects interact with each other by talking with fashion experts, by looking at data, etc. So there are a lot of MBAs and MBA students or people who are interested. For them also, I would like to say that there is a lot of problems here where it's a lot about business analysis. It's a lot about understanding the domain and helping being the data scientist. Now, I mentioned recommendation systems. So, a recommendation system recommends to users products and services based on their past purchases. And the core of many e commerce platforms, and most notably, two are platforms which we've sort of used more and more with the pandemic, Netflix and Amazon, are famous for their recommendation systems. And whilst taking away no credit from Netflix and Amazon, let me just say that fashion recommendation is a specialized recommendation system. It is specialized because as I said, to capture aesthetics, to capture design, it's not enough to build a recommendation system, uh, or a recommendation system built for something else will not work. Very quickly, a recommendation system is not an advertisement. An advertisement is a mass messaging. It is not a campaign where you push certain products and to a large number of large group of customers and hoping there will be a lift. Those are campaigns all of us get on emails and SMSs every day. Those are campaigns. A recommendation system is by definition personalized products and offers to use. Now, there are loads of different principles of recommendation systems. In the traditional recommendation system world, there is this concept of collaborative filtering, right? And then when I look at the modern AI-based deep learning recommendation systems, again, there are autoencoder-based recommendation systems. There are recommendation systems which are based on wide deep learning, wide and deep learning. There are various techniques, but underneath it, the reason why recommendation systems work is one underlying hypothesis that similar people buy similar products. Without this hypothesis, a recommendation system would not work. Now, underlying the maths that you would do, the architecture that you would choose will give you better results in some use cases, and for the other use cases, you may need different models. Now, I will show you a demo. This was a work that we had done, some of us, and this was presented in the CODS Commerce conference in 2019. This is one of India's top AI conferences, and we won the best paper award in the demo track. There's no audio on this. This is a screen recording. I will just take you through some aspects. So there is a chatbot, which this can be powered on any app, and someone comes in and asks for. So the chatbot starts and asks for looking at dresses, and then there is the person chooses a concept, which is party, and then chooses a type of garment fabric, which is satin. Now you will notice that satin is something that you would get on the data. Party is more of a concept. And then this recommendation system goes in and it gives some results. Now again, because this is we could not bring out the actual customer data for confidentiality purpose. These are public data, So the images are not great in that. This is from a public data set. But what I would like to point out is that this is what was actually built, and so you get recommendations for products, and then once this person chooses a product, um, there are these accessories that are recommended to her on different aspects of it. So you see there are three parts. One is the conversation part, which is where the person is chatting. Then there is the recommendation part, and then there is the complete the look. Now, for want of time, I will not go through the rest of the video. But if someone else logs in, then potentially that person will get a separate recommendation, and that's there. Now, how does this work? You have two aspects. One, you have the product. The product has the material. The product has a location, has physical attributes, and then you have the customer, who has a price sensitivity, who has a channel behavior, who has a history, which is the digital wardrobe, etc. And the relation between them is product is reflected in the purchase behavior, and the product preference says from the customers goes to design your products. So you have to understand your customer and the product. But let me just say product attributes is not product catalog attributes. And we'll look at some examples why. First of all, attributes are incomplete. These are real stats. 75%. This is perhaps slightly for one category, but on average, 60% of products have one relevant attribute missing. Relevant attribute means a collar on a shirt is a relevant attribute, but not on a trouser. Um, Attributes are inconsistent. When you look at these, especially say the two bottom ones, one is called checked and another is called checkered, right? What's the difference? You see a solid patterned weave, textured weave. These are examples of the variety that you see when you look at attributes that are inconsistent. And even if you were able to solve the first two, here is an example. Again, don't go and reverse search this image which site it is. That's not the point. The point is uh, the both on the left are printed, both on the right are checked, but look at the difference. Then there are these concepts of meta attributes: party, casual, formal, smart. What do they mean? They are complex attributes. And this is where we would need to build AI engines, which would not only look at the raw data, but would also look at the images. And this is what we did: build multimodal classifiers. So AI systems which can take in both the image as well as the product attributes to identify these complex features like Friday night, like interview. And by this, we enhance attributes by AI. We fill in missing gaps, we make them consistent, and we identify these meta attributes. Making sense of colors. This is a real problem. Colors are all sorts of color names you would get, and you will not be able to differentiate between them visually. And the other aspect that you face is that when you look at colors, if you look at the color names and try to go by color names, a yellow and an orange are as far apart as a yellow and a blue. That's really not the case. And how do you bring that about? And we bring that about by looking at the image, extracting primary and secondary colors from the image, and then doing certain distance metrics mathematically, by which we can identify the perceptual difference in color, not just RGB values, but perceptual differences. There are certain metrics which are used in computer vision by which two colors, whether a human being will look at those two colors same or not. So by bringing all of this together, we can build similar products recommendations. On the left is what you do without AI. These are blue shirts. This on the right you have examples when you combine data from images, text, build abstract attributes, etc. Just an example on why we need AI to make recommendations for similar products more relevant. And again, it's clear that its images are important. Here is forget about the details on the slide, but when you are trying to create something which will identify style, right? When we are trying to create something, when we want to understand what goes well with what, we would need to create this fashion database. And this is two similar products from IBM or two similar offerings, what I showed earlier in this, but they gave the same results, right? Uh, Style this with a certain cloth, with a certain other item. Now, this is not a rules engine. This is a deep learning based AI based system which learns from fashion data. Visually browse by similar products. And as you can see, similar products have attributes of either the same pattern or the same colors, uh, and that's the sort of similarity you would like to bring in. Was about uh, the experience part, and I'm having some problems sharing the audio. Suruta would show a video on how it is used in design. Let's look at it. It's a fascinating video.
Is the screen visible, Sujay?
It is.
Is it audible?
Yes.
So when the IBM approached us for this very exciting collaboration of this cognitive press, I thought it was something completely up my alley. This was a beautiful challenge because it was all these tech people coming from IBM to our factories, our seamstresses and masters and designers interacting with them and understanding how and when, how delicately have the lines to be put in the garments, and how would it drape, how would it function, the cognitive side of it. It is not just a dress, it's not just a gown, it's actually a sari gown. It is something which is very ethereal, beautiful, it's white, it is future primitive.
So this is the pairing of artificial intelligence with Watson. It's the ability to draw patterns and the creative inspiration and sensibilities of a designer like us. And the garment is designed to change its color and lighting based on individual personality.
That is magic. It's just opened the door for me, which is a door of another era altogether. It doesn't get better. बड़ौदा स्पोर्टिंग गुड्स इंडियन लिखा है. अच्छा, पर बेचते तो सिर्फ बड़ौदा में.
Thank you, Suruta.
Yeah, sure.
So, what the reason why I brought this one in is this use case is one where, and there have been quite a few where I would not say this is mainstream yet, but it will become mainstream over this decade, where design will be driven by AI because an AI model is able to go through large number of designs and then understand uh, what will work well, and it can also do a lot of experimentation, which is very difficult to do in a physical world simply because of the costs involved. So this is going to become very common over the next few years. There have been some work that's been done by both IBM and a lot of other competitors, and as well as many of the fashion specialists. I would not say it's fully mainstream, but then it's something that would become more and more mainstream over the next few years. And then here's one other example. It's about uh, what would be a lipstick, what would be a hair color, what would be a foundation that would look well, and how do you look at it? Now, the traditionally somebody would go to a store, and that would be, they would get a sample of it. But can we use artificial intelligence to do this? So this is again a demo app which exists, but we have a demo version of it here, where you choose an image of yours, and you can go ahead and choose a lipstick, apply the shade. So here, the artificial AI system, it's running on a phone app. It's identifying the lip, and it is applying the lip color. And it is adjusting for brightness. It's adjusting for natural shades. Uh, yeah, and it's even more interesting on the hair, but we do not have a version which can be shown to the public, which with the hair transfer. But again, with hair, you would want to, for example, if you look at this lady's hair, you would want these shades to be also maintained because you want it to be as natural as possible. So, and this is not something that we've done, but this is very famous on trying to identify um, the fitting of a spectacles. I do not have a demo of something else which we worked on for public consumption. A very interesting problem on fit, where we are looking at using 3D cameras to build a body model, and then trying to identify how would a certain dress fit on you. So if you really look at it from the point of interacting with the customer to the point of recommending to him or her what they would wear, what would be proper for them, for their face, for their facial, for their complexion, for their body shape, all of this is where AI is coming in. And then it's a very interesting problem. Again, we've just scratched the surface. There would be a lot of different problems that would come up. So I will stop here, and we'll have 10 more minutes for any questions. Surita, do we have any questions on the chat?
Uh, Not yet, but there are some questions which were posed earlier, Sujoy. So let
Okay.
me take those questions.
Someone has put one question just now. Let's see. Um,
Yeah.
Possible to explain the model. This is Vivek. It's a very good question you've asked. This is a problem.
So, shall I read out the question so that the others can also, those who are not seeing the chat?
Sure. Okay.
I will definitely read out the questions that it's clear for all. So Vivek has asked, Dev, you mentioned the cost of mistakes are low. Is it currently possible to explain the model, as in why a particular item was recommended to the user? Yes, sir.
Yeah.
Carry on.
Thank you, Surita. So, Vivek, it's a very interesting question around explainability. not just in fashion. This is a question which is being looked at in different AI problems. I would say, as of now, the explainability features are there, but there is standing today, there is some trade off between explainability and, if I use the word loosely, accuracy. So there is some trade off between more advanced models being less explainable than others. Again, as I speak, there is a lot of work happening in explainable AI, uh, and uh, and so there's been some. It's possible to some extent, but not really to a large extent. However, I would add something more, and this is more of a personal opinion. Uh, when we really look at even a physical store, and if someone is recommended a shirt, um, the person or a dress, the salesperson or the fashion expert would say, "Madam, sir, this is suitable for you," but won't really give you five different reasons. So, so yes, explainability is coming in, but not really. I won't say it's up there completely, especially as you go for more complex and more accurate models.
Sure. Thanks, Vijay. Vibha from Vibha Fashions has the next question. How AI can be used in manufacturing of women's apparel?
Uh, uh, there, in the manufacturing space, AI is more used in the design, as I showed in the examples, as also some recent work we are now doing on quality checks, where we are trying to identify whether a cloth, either right from the right, and you can do it right at the bale cotton bale level to the processed cloth, whether the cloth is of a good quality or not, by looking at it from, I would loosely use the term, by using a digital magnifying glass, a specialized magnifying glass. Also, whether the print, etc., has been as designed or as expected, whether there are any defects in the manufacturing and the printing process. So this is work which is, some of it I'm doing right now. So this is work that's happening today, and yes, so there is work. I would not say it's right at the top of success stories, but there is work in quality checks as well as design.
Great. Thanks, Vijay. There is a question from Vibhu Sharma. As mentioned by you, texture and feel of the fabric is a big consumer interest point. Is there any model technology through which we are trying to solve this for online purchase?
So it's not about the model. It is more about the sensor. Do we have sensors we can express, by which we can digitally communicate texture, or feel, fabric, more of the fabric. Uh, to the best of my knowledge, that's not possible, right? If you are saying that this cloth has a silky feeling about it, it's a conceptual thing. That feel cannot be really digitally transferred. So it's less of an AI problem than a sensor and a communication problem. Uh, so I would say that this is one part which is still in a very infancy. But by using these multimodal approaches, where you combine text and images, you can get some aspects. So, for example, some aspects of the image will come up, of the texture will come up in the image. So you can use that for your AI models. But the real feel, no, it's not there, to the best of my knowledge.
Sure. Thanks, Vijay. Um, Shashank, we will take your question at the last because that is something which will be applicable for everyone. Abhinash has a question. Abhinash is asking, do we really understand how an AI makes decision explicitly? Can we identify based on which variables it makes a particular recommendation?
I'll take the two parts of your question separately. When you say really understand, uh, do we understand the maths of how it works? Yes. Do we understand what is the effect of a certain attribute on the recommendation? It's far more complex because it's a nonlinear system. It's a where lots of variables come in and interact with each other, right? It is not only about color. It's a combination of color and print and fabric and brand that all come together when you make the recommendation. So again, as I said, there is work on explainability that's happening, but do not expect it will say uh, this dress is recommended for you because of the color. Because no, none of us go to the shop and say, I will buy a red dress today, right? We would have something in mind, and then we would be exploring in that way. So it's a little more nuanced than being able to say which variable makes a particular recommendation.
Sure. Uh, Harshit Srivastava has a question. How much time would it take for AI to come mainstream in fashion industry?
I would say it is already mainstream in the product recommendation part, right? In the product recommendation part, in the similar products, AI is the mainstream, right? What it is not yet the mainstream is is the design part. There, it's coming up. My personal guess is within the next 5 years, it will become mainstream. 5 to 7 years, it will become mainstream. But if you look at the online experience that you and I do, it is AI underneath. So it is mainstream in that part.
Sure, thanks. Ankur has, I think, a related question. Could you share some of the top companies using AI in e-commerce for grocery business?
I would not name companies, but I would say all companies who are doing e-commerce in this would be having some level of AI. Some may be more mature, some may be starting on their journey. But some level of AI would be present in any e-commerce system.
Sure. Mayuk is asking, Nike introduced crypto kick non-fungible
Non-fungible token,
yeah,
NFT.
yeah, to combat counterfeit sneakers. How AI can be used to combat counterfeit in fashion?
This is a very interesting problem because as I speak, we are working on a problem on Nike sneakers. As I told you, there are these instruments which are effectively digital magnifying glasses, right? And what is if you ask an expert to identify an original versus a fake sneaker, they would look at things like is the stitching correct or not, is the material correct or not, and by using these digital magnifying glasses embedded on a phone, uh, you can identify this. This is experimental work, but this is possible. So again, I'm not saying it's out there, but I'm saying it's in the process, and there is a lot of work happening on identification of counterfeit in by using AI.
Sure. Okay,
So Nitya,
Swapnil,
let's take two questions more, and then we've got one question which you parked.
sure, fine. So let me.
So someone has a question: can an AI develop biases in its decision? Again, one of the top research areas in AI. AI does have biases. This bias is because AI is trained on data. If your data has bias, your model will have bias. For example, if I'll give you an example on fashion, since you're talking of fashion. If you train your data that boys will wear blue and girls will wear pink, and then you train an AI system, and then your AI system predicts blue for boys and pink for girls, don't blame the AI system. It's the problem with the data, it's the problem with how you have done it. Don't say that the AI system is sexist because it is learning from what is given to it. So biases are present, uh, and biases, and we have to make explicit choices to eliminate bias. uh, all AI companies have ethic boards. All companies which work on AI have ethics boards by which these are reviewed. You have to be very careful that you do not break, do not create these biases. Again, we have to understand that society is becoming more acceptable, open towards people's dress choices, people's lifestyle choices. But this has to be reflected in your data. An AI system on its own cannot do that. Let's take one question from Raj. Last question.
Sure. Raj, are you there on the call?
Yes.
Yeah.
Uh, Sir, so thank you for your session, sir. Very insightful,
Thank you.
first of all. And my question is regarding AI and data crunching. Basically, data is considered to be oil right now, and these things got into the light after Harvard also published one of its news about it. So, as we know that AR and virtual reality at one point of the time was the next new thing, and right now is AI. But the VR didn't went on to become what it was supposed to be. It also depends upon how much it is acceptable by the users. We see all the products that are being made with the predictability, and it has to be accepted by the users. So, what is your opinion about AI coming into all the facets in different uh, sectors and not getting the same results as that of the VR?
Let's just understand. Even AR VR. Why look at AR VR? Look at AI and the history of AI. AI has had three winters. 1960s, people had thought this was a 2 years problem. Uh, and then there was a huge winter, the first AI winter from mid 60s to the mid 70s. Then there was the AI winter in the 70s. Then there was an AI winter from mid 90s to 2010, 11. Nobody used to use the word artificial intelligence. It was a term which was not used. It was almost like a bad word. Uh, the reason is overhyped expectations. The improvement that AI models have done over the last 10 years is amazing. Some of the things that these models can do, you would not be even be able to think of it 10 years back. So there has been huge success. However, there is no magic wand. This is not Harry Potter, right? This is pure maths happening based on data. So we have to maintain expectations as practitioners, as sellers, as consumers. We have to maintain expectations of what is possible, what is realistic. If we keep realistic expectations, I think AI truly has the potential to change all industries over the next 2 decades.
Right.
So
Thank you.
you
Thank
had
you.
part one question. Let's take that as the last one.
Sure. Before that, Sujay, there is one very pertinent question, and this is for,
Sure.
there are a lot of entrepreneurs also who are on the call, who are related to the fashion industry, right? So you can just answer it very quickly. How affordable is this system for any store or website if they are not big players in the market? This is basically, for all the entrepreneurs that we have on the call.
Um, a lot of the work today is open source, right? So I would say of all the things that I showed, all of them underlying it more or less is based on open source work. So you don't have any software costs. The costs that you bear are the skills. You bear the costs of skills, and data scientists are not the cheapest in the industry. So I would not say it's really a huge software investment uh, where you have to spend $1 million to get some software in, but you do have to spend on getting people, but more importantly, getting a strategy. Right? What is important is what do you want AI for? If you want to do a system by which someone can use a complete the look for or virtual try on for clothes, then that you should focus on that. But don't try to take up everything, because this entire area is huge. If you want to work on design in AI, that's one problem. So having a strategy is as important as having the skills. The software costs are really negligible. There are some hardware costs, GPU costs, but they also are becoming much and more affordable over time. But the real thing is, do you know what do you want to do AI for? And I've seen a lot of companies make a mistake on that decision.
Great, thank you. That's a great answer. And the last question which I had parked from Shashank. What would be your suggestion to a AI beginner enthusiast from a non-IT background to understand about its basics?
Let's just understand that AI is not only about data science. There is an entire the spectrum of roles. There is someone who will conceptualize a solution. There is somebody who will work with the specialists as a business analyst. There would be people who would be processing the data. There would be people who will be building the models. There would be people who would be deploying them and managing the models. And there would be people who would be looking at the results and trying to interpret them and identify business impacts on direct business impacts. If you really look at it, half of these are non-technical roles. So do not think that you cannot participate in AI if you do not know data science, if you do not know IT. Right? You can participate in AI, and your participation is no less important. If I may say, it's perhaps even more important to have sellers, to have decision makers who understand what is feasible and what is not feasible in AI. So it is not purely a technical role. On the other hand, I do not go by what some companies or some organizations say you can become a data scientist without knowing technology. No, technology is heart of data science. But can you contribute as a very important player in the AI journey of organizations without being a technologist? 100% you can. I'm convinced of that. I would not be able to do this work without the business analysts who collect the requirements, without the sellers who communicate with the client. It would not have been possible to do the work. So there are lots of roles in which you can contribute towards AI.
Great. Thank you so much, Sujoy,
Thank you
for
for
the
the
wonderful.
opportunity. It was an honor to speak for GoCracket.
Thank you very
It
much,
was a
Sujay. Thank you very much.
it was a wonderful session. The way you covered it, right from the beginning of what we are seeing as users to how things work in the backend and what's the future going to be. It was really a great session. Thank you very much, Sujoy.
Thank you.
And thank you everyone for attending today's session. I would also like to thank Alok and my GoCracket team members, Shiva and Vidya, for helping out with the session. Thank you everyone. Thank you, Sujay.